Okay, so this is for 11.3. We're on page 767. It says here that Euler also found the sum of the p-series with p equals 4, the sum of this, 1 over n to the fourth. He actually found what the sum was. Okay, what we do with the p-series test, we just determine whether it's convergent or divergent, right? And that's really all the AP test is going to be asking you to do. But Euler came up with what the actual sum was for 1 over n to the fourth. So if we're using this sum here, we're going to do a similar thing with this. What can I do with a fourth power if I have a quotient? Yeah, so this will be 3 to the fourth over n to the fourth, right? And then if I have this, what can I do with that 3 to the fourth that's a constant? Well, and can't you just pull the 3 to the fourth out front? Okay, so let's do that. Equals 1. Up to infinity. Okay, so I'm going to pull that 3 to the fourth out front. So this is really 3 to the fourth times the sum from n equals 1 to infinity of 1 over n to the fourth. And then can't we replace this portion of it with what Euler found? So really we have 3 to the fourth times this. So questions on that? Okay, so part B is a little bit tougher. Part B says we've got the sum, and we're starting where? At 5 here, right? So what I'm going to do is I'm going to list some of these out because I think that's the easiest way to see what's going on here. Okay, so if I start listing some of these out, first value I'm going to plug in is what? 5. So if I plug 5 in, I get 1 over 3 to the fourth. I'm just going to leave it like that, okay? The next one is going to be 1 over. So I'd plug in 6, so I would get 4 to the fourth, and so on, right? Is everyone okay with that? Okay, now let's take a look at his part up here. So let's take a look at this part right here and list out some of the terms. So if I listed out some of these terms, if I plug in 1, I get 1. If I plug in 2, I get 1 over 2 to the fourth. If I plug in 3, I get 1 over 3 to the fourth, 1 over 4 to the fourth. Okay, and then dot, 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 right? So if I am comparing these two, isn't this portion equal to what I have below? Okay, so this, let me just write it out very thoroughly here. So this 1 plus 1 over 2 to the fourth plus this 1 over 3 to the fourth, 1 over 4 to the fourth, all of that's going to be this sum here, right? I'm just trying to think of what's the easiest way to write this. Let me just keep going with this. Some of you might see what's going on here, and some of you might still be confused. Okay, this whole thing is equivalent to what? Okay, it's equivalent to this, which is equivalent to this, right? This is our number value of what this whole thing is going to be. So let's write that this is equal to pi to the fourth over 90. And now can't I replace this stuff back here with this right here? Okay, so I'm going to do that. Yeah, because this starts at 1 over 3 to the fourth. So this stuff here is equivalent to this here. Right, when we plugged 5 in and then plugged 6 in, okay? So instead of writing this 1 over 3 to the fourth plus 1 over 4 to the fourth, I'm going to put this into its spot. And that's what I'm trying to solve for, right? So how would I get this piece by itself that I'm writing out right now? Subtract the other two pieces over, right? So if I'm trying to get what this is equivalent to, I'm going to subtract the 1 over, and I'm going to subtract the 1 over 2 to the 4th over. So this piece here is equivalent to pi to the 4th over 90 minus 1 over 2 to the 4th. And that's correct to 3 decimal places, so I'm going to circle it. Okay, so for 23, can we use the p-series test for that? Yeah. No, so then we have to use, because of the section we're in, the integral test, right? So we're going to take the integral from 1 to infinity of this. And I suppose I should have used x's again, but I didn't. Okay, so any ideas on where to go with that? Okay, so let u be 1 over n, and I'm going to write 1 over x because I assume that u would switch those to x's. And the derivative of that would be derivative. So it's x to the negative first. So you pull the negative 1 down, and then it's x to the negative second. Or, sorry, x to the negative second. So I put negative 1 over x squared, and then dx. And then if you solve for dx, you would get dx to be negative x squared du. And that should cancel that piece out. So if these are x's instead of n's, which they really should be, then replace those. And what do you have to do with the infinity if you want full credit for things in the test? Do the t thing, okay? Okay, I kind of skipped this on 23. We need to actually do the 3 things at the beginning here. So do we know that this is always positive? So if you plug 1 in, what do you get? Which is? 0. So it starts out 0, but then if we plug in things bigger than 1, think of the natural log graph. Okay, if we plug in things greater than 1, isn't natural log positive when we're talking greater than 1? Okay, so this is going to be positive, and when I'm plugging in things greater than 1, this will be positive, right? So we know that the natural log of n over n cubed is going to be positive. It's okay that it starts out at 0. Okay, so it's positive. And we're not going to say from 1 to infinity, but we'll say from 2 to infinity. And that's okay, because at 1 it's 0. Okay, but after that it's going to end up being, or you could have an open parentheses, I suppose, from 1 to infinity, but we're only plugging in integers, so we might as well just start at 2. And then is it continuous? So is there any spot it's going to have issues? No, so it's positive, and then we can also say continuous here. Yep, so those are the first 2 things. It's positive, it's continuous. Now, yeah, trying to show that this is decreasing, what would you have to do if you can't just plug in values on your own? Take the derivative. So let's just do that just for practice here. Okay, so f of x is natural log of x over x cubed. If I take the derivative of that, what do I have to use? Low d high, so let's do that. Oh. Okay, so low d high minus high d low over the bottom squared will be over x to the what? 6. Okay, so x cubed times 1 over x would be what? X squared, and then minus 3x squared natural log of x over x to the 6th. Can't I actually take some stuff out of there? I can take an x squared out of everything, so I would actually be left with 1 minus 3 natural log x over x to the 4th. So isn't this always positive down here? So really I just have to worry about the numerator being positive. So we set it equal to 0, right? And then I would add this over. And then how do I get natural log x by itself? Divide. So I have natural log of x is equal to 1/3. And then I do what? Yeah, I go e to that power, exponentiate it, right? So I get x is equal to e to the 1/3. And then you can do your quick little number line. So I'm going to write here the derivative equals 0 when, just so my writing here is correct. Okay, so then doing our number line, e to the 1/3. I'm plugging into the derivative. So if I plug in something bigger than e to the 1/3, like e, it's negative, right? Because natural log e would be 1. Yeah, plugging in the derivative. Okay, and if I plug in over here, it doesn't really matter, but if I plug in over here, I'm assuming it's going to be positive, but does it really matter what's happening on this side? No, as long as it's eventually decreasing. So it's decreasing where? E to 1/3 to infinity. Yeah, e to the 1/3 out to infinity, so it's decreasing e to the 1/3 to infinity. So it's eventually decreasing, right? Not including because at this spot it's 0, so it's not increasing or decreasing, okay? It's actually probably, you know, like a local max. So. You just have to make sure it's decreasing as it goes out to infinity, okay? So we have those three pieces. Now we can do the integral test. So let's try the integral test here. We have natural log of x over x cubed. And we're going from, what was it, 1 to infinity. So I'm going to go from 1 to t and just switch my notation right now. And take the limit as t goes to infinity. So questions on that part?
So if it's not decreasing.
Okay, any ideas? If we try to do like u substitution, because that's typical if you have natural log x here and an x down here, that would work. But if it's x cubed down here, that's not really going to work. So what's the other thing we use if there's like a product type thing in the integral? By parts. So that's like the u and the dv. So what? Where would natural log x have to go? Here or here? The u. Okay, so we'd have natural log x here. So this would be x to the -3rd, right? Okay, take the derivative of this and we get 1 over x dx. And take the antiderivative of this and we get Okay, that's better. Okay, so we have x to the -2 because we add 1 to the exponent, right? And then you divide by this here. So close, yeah. So we have -1/2 of that. Sorry, that looks awful, so I'll fix that here. So we have -1 over 2x squared, if you want to write it like that. Does that work for everybody? Okay, so now we do u times v. So this times this. Yeah. So that's our u times v minus the integral of v du. And then I think you should be able to finish it from there.